So for this video, I'm in my basement where I have taken a picture of what's sitting on my workbench. So you'll see here I have three containers. I have a computer, I have a glass vessel, and a plastic vessel. The plastic vessel has water in it. And this one has denatured alcohol, which is primarily ethyl alcohol. And this is acetone. Acetone is the same stuff that's found in fingernail polish remover. What I'm going to do is put a little paper towel on the end of this temperature probe. And as the experiment continues that I'm going to do for him, the temperature will change because of the evaporation of the liquids. Remember that evaporation requires energy. So if energy is required, then the temperature should go down. That is, the temperature of the probe should go down because energy will be being put into the evaporation process. So I was going to show you how I wrap it up and set up the experiment, but my webcam's not working down in my basement very well. Must be because of my internet connection. So I'll just do that on the side here. So what I'm doing right now is rolling a piece of paper around the end of the paper towel around the end of the temperature probe. And I have a paper towel wrapped right here. All right. Behind this I have Logger Pro. And you can see that the temperature of my temperature probe right now is 17 degrees. I'm opening the acetone, and I'm going to put the acetone into that little glass vessel that you saw a minute ago. My acetone can is about empty, but I got enough in there to make this happen. So I'm going to put the paper towel into the acetone. You can see the temperature may change. But it didn't, so it's about the same temperature as the room I'm in. And now, went up slightly. I'm going to take the probe out. I want you to notice what happens to the temperature. And we're going to let this run for a moment. You can see that the temperature is going down. I think we'll run it out for, if we were doing this in class, I'd probably have you run it for 1.5 minutes, or maybe 3 minutes even. But since we're doing this in a video and they get kind of long when I upload them, we will just run this for maybe 1 minute to 1.5 minutes. Temperature is getting fairly cold. Notice it's down to 7.4. What is the freezing point of water? Do you guys remember that? That'd be 0 degrees C. So I'm starting to approach the actual freezing point of water here just by evaporating acetone. Now, girls in particular, you may have sometimes taken fingernail polish off of your fingers by using acetone, and you'll remember that when you put it on your hands, it does feel cold. Even though it can't be cold because it's sitting around in the room with you, so it should be whatever the temperature of your room is. But it feels cold, and this is why, because the acetone is evaporating. All right, so I'm going to stop it at 100 seconds. That's a little over 1.5 minutes. You can tell it got pretty cold. So we'll stop there. Now I'm going to store that run, and we're going to do another experiment, but this time I'm going to use that can of denatured alcohol that I had sitting there a minute ago. So you remember the image. So what I just did was I took a paper towel, put it on here, dipped it in this little container, which I had acetone poured into, and the acetone evaporated, and as it evaporated, it got cool. So I'm going to put another piece of paper on the probe. I'm doing that right now. This time, I'm going to use ethyl alcohol, or ethanol. That's the can of denatured alcohol that you see there on the left. So I'll open that up. Pour some alcohol in my little glass container. And we'll put the thermometer in, so we'll get that going. I stored that run. Temperature, you notice, is coming back up. So we'll put this in alcohol. The alcohol's been sitting in the room, so the temperature is going to rise. I'm going to hold it there until the temperature stops going up. I expect it to go up to around 18, maybe 17, maybe 15. Here we go, a little more. This last one started at about 18, see right here, so 10, 12, 14, 16, 18. But I may not be able to get it above 16. All right, so let's go ahead and just start it right there. And so we're starting to graph it. You see the blue line coming. And I'm holding the alcohol probe, or the temperature probe, out into the air, and the alcohol is evaporating. You can tell that this time it's still getting colder. So energy is being absorbed as the alcohol evaporates, but it's not getting as cold as the alcohol, as the acetone did. This is ethanol, and the ethanol is not getting as cold as the acetone did. The temperature is not as low, although it is definitely getting cooler. So is the alcohol using energy to evaporate? Sure. Is it using as much energy as the acetone did? The red line? No. So the red line was the acetone, and it evaporated much more quickly than the alcohol is evaporating. We know that because the temperature got much colder, or much lower. All right, so we'll run this out to about a minute also. Maybe over 100 seconds like we did before. I'll keep them consistent. Okay, so we'll stop that. We'll store that run. And we will put another one on there, and this time we're going to do water. And I had water sitting in the cup. My rubber band on the paper towel. And this is the water. So I'm putting the temperature probe into the water. Should be in that 16 to 17 range. That's about right. Okay, so here we go. We're going to start collecting the water. The water's kind of following the alcohol line, but now they're beginning to diverge. So while this is running, maybe we could, I'm not sure if I can annotate here while it's running. Maybe I can. So this would be water. And we also had alcohol. Get my fingers in the right spot. That's actually ethanol. And the ethanol was the blue line. So let's change it so that it shows it was the blue line. It's interesting that water is not really getting much colder, is it? All right, and then we're going to insert another text annotation. We're going to call this one acetone. That was fingernail polish remover. We'll put that down here. All right, so now we have our 3 lines labeled. We'll stop it right there. Now I'm going to auto scale. That may change my labeling slightly, but that makes it a little bit more dramatic in terms of looking at the picture. There's the water. The acetone was the red line, and the alcohol was the blue line. So you can see that there is certainly a difference in the drop in temperature between the three liquids. The acetone went to the lowest temperature, and the water went down a little bit. So if you look at the beginning, it was 16.4. If you go down to the end, it was 16.1. So it's a little bit lower over here than it was over here. However, it didn't really, there was no dramatic change. There was just some change. So 16.4 down to 16.1. But the acetone was dramatic. So this unit's about why is there difference? Why are the rates of evaporation different? So I'm going to ask a few questions on a little online quiz, and then we're going to learn how to draw pictures of molecules, and we'll actually draw these and see if we can figure out why some molecules stick to each other better than others do. Of course, this affects things like boiling point and melting point. It helps describe properties of things around us, and it helps explain why acetone feels cold when you put it on your skin, or even rubbing alcohol feels cold. And water doesn't feel as cold, although water does evaporate as well. That's why you feel cold when you step out of the shower or when you step out of a swimming pool. All right, so we'll end this video here.